Good morning, good afternoon, good evening, everyone. Thank you very much for attending this webinar. I will be your host today. So my name is Virassamy. I'm a principal solutions architect working for Mirantis for about 4 years now. I live in Paris. I've always been in the open source world, right? Very curious by nature, but open source by choice. Been working with Linux since the early 2000s, OpenStack and Kubernetes since their inception. So today we'll be talking about open source and how actually we can evolve your VMware estate into a future-proof open cloud infrastructure, right? And as you can guess from the logos, we'll be talking a little bit about OpenStack, but we'll also be talking about Kubernetes. Okay, so what do I have on the agenda for today? We'll be talking about why we need to consider changing and what are the actual options, right? And this comes from what we are seeing on the field, experience we as Mirantis when we talk to different customers across the world, and how then we are collocating all these options and sharing that with you. We'll be talking a little bit about OpenStack. So back to the basics around OpenStack, the main use cases of OpenStack, some success stories, concept along what are the core and extended features of OpenStack, workload and hardware support for OpenStack, what are the deployment patterns that we typically enforce and with the enterprise-grade integration, and also what would be a recipe to succeed with OpenStack. Then we'll talk about Kubernetes. Again, Kubernetes has a disruptive approach. Why disruptive? Simply because when we talk about VMware, we are talking about VMs. So why Kubernetes in the picture? But again, here, I think Kubernetes can be a good approach. We'll be talking about not only refactoring code, but rehosting applications, and why not Kubevirt? So why consider change, and what are the options? We all know now that VMware is going to be acquired by Broadcom. This is going to be finalized in the coming weeks. And around that, many companies are already raising some concerns, right? So basically, there are concerns around pricing. We all expect that there will be an increase in price, right? Even VMware right now is not able to guarantee that the price will stay the same. So that definitely raises some concerns. The quality of the support, really don't know what to expect there. Whether the support will still be at the same level of what we already know now, or basically will just be lower. The product roadmap, and this is where we have the biggest question mark. What are the products that will remain? What will be the roadmap for these products? Can we expect a shrink in terms of features? We are already seeing things around like Flinks.vmware.com. That was the innovation lab of VMware for the last 10 years. A lot of projects came through that hub, and very recently there was an announcement that the portal was going to be stopped. Right. So that's just some examples of why enterprises are getting these concerns, and they are getting some data, some feedback from VMware themselves, that is not basically giving them more confidence, right? We also know that Broadcom has a strategy around acquisition. We've seen that with Symantec, we've seen that with CA Technologies, right? And typically what happened when through these acquisitions, what happened at the time was less focus on partners and more focus on top customers only, right? Actually, they already shared some numbers at the beginning of the process when they announced the acquisition of VMware. They already announced some numbers, around 700 or 400 customers around the world. But then they stopped that messaging and said, okay, we are going to not focus on these top customers, but we'll manage that a little bit differently, right? But again, that's part of the I would say the Broadcom acquisition strategy in general. And that's also bringing some concerns. Some of the organizations have that bad experience, I would say, with Symantec and how that was managed by Broadcom, and they want to find something or they want to have a plan B when it comes to managing virtual machines in their private cloud. Even Gartner suggested to have a plan B at some point, right? If we look at some of the messaging from Gartner beginning of 2023, they highly suggested to start to looking at some plan B for private clouds. And finally, I think one of the things that we also understood by talking to various parties across the world is that there is a pressure for ELAs, right? So VMware right now is putting a lot of pressure on trying to sign as many ELAs as possible. And basically why? Because of to secure some pricing for the next 2 or 3 years. Even though that maybe seems to be a good deal for many of these organizations, ultimately, one, it's never good to sign something because of pricing pressure, one. And two, that's just postponing the problem to the next 2 years or 3 years. So that's where the plan B is definitely required. All right. So these are some of the concerns that we are seeing from, or the feedback that we are getting from our customers. Then what are the considerations then that needs to be taken care of when it is to selecting the proper option? The first question is, do we need or do you need to use only VMware? I think no, but we'll get into these more details in the next slides. But I don't believe that now with all the various options that you have, you can only, or do you need only to go with VMware. There are some proper alternatives on the market that allows you to get the same level of services and resiliency with other solutions. Do you need to move everything to public clouds? Again, no. Right? I don't think that this is the right answer also. I'm not saying that public cloud is bad, but I do believe that putting all your eggs in the same basket is a bad choice, right? You need to have a true multi-cloud approach, whether it is multiple public clouds, but also have some private clouds to be able to move around your workloads in the right place. We did in the past a few webinars explaining some of the benefits of public clouds, but also some of the drawbacks of these public clouds and how data should be managed to reduce and manage the proper cost structure. Can you have a disruptive approach when it comes to plan B? Yes, definitely. And this is why we'll be talking about Kubernetes. Can you have a customized solution? Definitely, yes. That's one of the biggest advantages of open source solutions, is that you can own completely the project, own completely the code, and make it yours. And finally, can you improve your cost structure? Yes, you can, by making the proper choices in terms of hardware selection, in terms of software selection, and in terms of automation around managing this infrastructure. So VMware to public cloud, is it a good option? Maybe, maybe not. You do have tooling now with VMware on public cloud that allows you to migrate your application more rapidly from VMware on-premise to VMware on Amazon Web Services, for example. But here in your case, that may be not the right choice, because you want, again, to reduce the licensing cost of VMware, or you want to move away from VMware because of all the concerns you have, or all the uncertainties you have around that acquisition by Broadcom. So basically, then you'll need to migrate that into something else, right? So migrate that from VMware, for example, to EC2 instances. And that's a process that you'll need to go through, which is not that straightforward, right? That's a migration process that you're going to do from a proprietary system to another proprietary system. And if you want to go on another proprietary system, like let's say Azure, that's another migration, right? So this is something that you need to take into consideration when it is to go towards public cloud. Is this the right approach? Are all applications fitted to move to public clouds? And what will be the cost structure when we have all these VMs on public cloud running 24/7, because this is a production environment, right? So you do have an increasing cost of the migration for sure. This is also something that we got as a feedback, right? So the migration is typically funded by various parties. And then ultimately, once the workloads are migrated on top of these public clouds, you start to pay for the resources actually, right? And this is where the cost is higher than what you have observed on your private cloud. You also have the lock-in mechanism with egress cost. So once you have put your data on a public cloud, it's very, very hard to move that data out of public cloud because of the cost structure of these public clouds. So again, that's why I say multi-cloud is a very good approach, or / the best approach, where you need to decide where to put your workloads and associated data to make sure that you are never in that lock-in situation. Right. And then again, it's a closed solution. So moving from VMware, which is a closed solution, to another closed solution, not sure that's the best, always the best option. So is in this case, is open source a concern? Well, I don't think so, right? Because if you look at the open source today, the open source portfolio, you have rock solid projects, whether it is in the database space, whether it is in the development framework space, right? Whether it is storage, whether it is orchestration for virtual machines or containers. So you have a lot of these very, very high level, high standard projects that millions of people are using on a daily basis, right? So can open source be considered as or products or components that are or that have lower value than closed source solutions? Not really sure, right? Because here on the closed source solution, you have that pack of well-known brands like Red Hat, OpenShift, AWS, Azure, GCP, VMware, Windows operating system, right? Very, very well-known brands. But on the other side, you can have competing products that work very, very well. And actually, many of these companies are actually using some of these projects within their framework, right? So I don't believe that open source is a concern. There are very, very good projects in this space, and the solution to replace VMware, right, Plan B, can come from that space. Definitely can come from that space. And I said replace here, but it doesn't mean replace fully, right? One of the approach that we typically see also is that the idea is not to fully replace VMware, but to complement VMware. So basically, you start to reduce the footprint of VMware and look at some very, very specific workloads that will be migrated on top of an open source platform, whether it is OpenStack or Kubernetes, for example, right? So in that case, you start to reduce that footprint. You reduce that footprint, meaning that you are paying less licenses. And on the other side, you have that alternative platform where it is, workloads are adapted to run on these platforms, again, managed through that open source concept. Saying that, this is how, for example, you can then start to think about how to define that open source multi-cloud solution, right? So if you look at that map, here you would see that you are coming from a given environment, which is more or less closed source, right? Whether it is VMware, Nutanix, Red Hat, OpenShift, right? So you have these closed source solutions that host your different applications. And as from there, you can move towards various open source solutions, right? And here, I mean various open source solutions in a very, very broad way, in the sense that think about it in a multi-cloud approach. You can have some of the applications moving towards OpenStack to host virtual machines. You can have some of these applications move towards Kubernetes, right? Kubernetes for containers. And you can have some of these applications move towards public clouds, right? So the idea here is to look at your source application. Some of these will stay on that source application for various reasons, because you can't move them, because it's certified to run on VMware and you are supported on VMware, right? So you can't move them from VMware, for example, right? But others are made to or adapted to move on the other platforms, whether it is on-prem or public cloud. When it is on-prem, then you have OpenStack option, you have Kubernetes option. When it is on public cloud, you have Kubernetes option or the various services provided by these public clouds, right? So you do have options to create that multi-cloud open source solution based on the application properties, and also based on how you would be able to reduce the cost, because at the end of the day, it also needs to be economically interesting, right? So let's look now at OpenStack and how we can build that rock solid OpenStack platform, right? Again, this is one option. This is not the only option, but this is one option. So let's do that very simple comparison, because very, very often I get that question of, okay, I know VMware, but I don't know OpenStack. How can I map services from one world to the other, right? So for that, we've done a very, very simple mapping where we have kind of explain how some of the VMware services would find an equivalent into the OpenStack world, right? So let's look at the left side. Sorry. So on the left side we have the SDDC manager, for example, to help deploy and manage the infrastructure or the infrastructure as a service layer, right, or the virtual infrastructure manager layer. For the OpenStack side, Mirantis, for example, have developed a component which is called MCC, Mirantis Container Cloud. And Mirantis Container Cloud is used actually to fully deploy the OpenStack solution. And what I mean by fully deploy is onboard or provision the physical machines, install the operating system, configure the operating system, and then configure the OpenStack services on top of these physical machines, right? Then if we look at the vCloud Director, this is something that does not exist in the OpenStack world, right? But can be built through either your own development or some custom development provided by professional services, right? So if you do need to have that vCloud Director to manage multiple services across various clusters, this can be built, but off the shelf, this does not exist in the OpenStack world. Okay. If we look at the container story with Tanzu Mission Control and Tanzu, with again OpenStack, you have various solutions to do that. You have Mirantis. We provide through Mirantis Container Cloud. We provide Kubernetes as a service with Mirantis Kubernetes Engine, right? So this is coming through our product offering. But you have other solutions in the market. So you can deploy using some specific projects within OpenStack that will give you Kubernetes as a service or container as a service, right? Like Zoom, for example, is an example to manage these containers within OpenStack. But you can use other projects like KubeADM or any other projects of vanilla Kubernetes or even proprietary Kubernetes that runs on top of OpenStack, right? OpenStack hosting virtual machines will allow you to host these Kubernetes clusters. So that's a big difference also, because here typically this is related to Tanzu and you have a lot of deep integration between Tanzu and vSphere. While here you can plug any vanilla Kubernetes or any standard Kubernetes on top of OpenStack that will work out of the box. On the virtualization layer, we will so to map that from vSphere to OpenStack. Here we have the OpenStack projects to manage the hypervisor, the virtual machines, right? So ESX hypervisor mapped towards KVM hypervisor. The vSphere networking with VLANs is mapped with OVS, so Open vSwitch SDN. Noting that the vSphere networking is typically very, very simple, right? It's provider type network, provider network layers. So very, very simple networking with VLAN-based networking. With OVS, you can do way, way more because it also supports an overlay and you can do already do some micro segmentation within OVS, right? If you want to have some more complex networking in VMware, you will have near NSX, and with Mirantis OpenStack, for example, you would have Tungsten Fabric or an SDN coming from the Juniper that allows you to do advanced SDN with advanced micro-segmentation of your applications. Okay. In terms of storage, vSAN for hyperconverged on the VMware side. And with OpenStack, we also do hyperconverged. You can do hyperconverged with any SDS. And in that case, we are talking about Ceph as the open source SDS. But you can also do hyperconverged with another SDS if required. All right. And external storage is supported in VMware as external storage are supported in OpenStack. You have various drivers that have been written by multiple storage parties, like Pure Storage, NetApp, that you can integrate into OpenStack. All right. When it comes to the management piece, where you have vRealize and Tanzu Observability, on the OpenStack side, it's the same. You have various plugins that you can use to do proper observability or logging, monitoring, and alerting. For that, Mirantis, we have developed something which is called Stacklight, and basically what the Stacklight is based on open source projects like Prometheus, Grafana, Kibana, OpenSearch, that allows you to get better visibility of the OpenStack cluster. But you can also integrate that with other third-party storage LMA systems like Datadog, for example, or Splunk, to get better observability of the cluster. Right. So you have again these open APIs that can be used to hook with any systems to kind of monitor your solution. But here in our case with Mirantis, we provide the full stack with our OpenStack. Okay. So this is a very, very simple comparison of how we can map some features from VMware towards OpenStack. But now, if we look at it in a little bit more details, I think we should avoid to have that one-to-one comparison, because ultimately, what we are getting from OpenStack is a lot of services, right? And the way that it is managed in OpenStack is you have these projects, and here you have a list of, or it's part of the list of projects that are available in the OpenStack community. I'm not going to go through all these different projects, but yeah, it's composed of multiple projects. And the good thing about OpenStack is basically you can then start to select which components that you want to integrate within your OpenStack to make it yours, right? So that's why you have that bespoke part on point 3. And maybe I should have put that on point 1, simply to say that as it is a composable solution, you can make it really yours and adapt it to your use case. So you can have an OpenStack cluster tuned for a given workload, like AI/ML workload, or you can have an OpenStack cluster tuned for big data kind of workloads, right? To create your data lake and then have some ETL jobs that are run in the cluster. You can build OpenStack clusters for telco use cases, so network IO intensive workloads, where you would only select the networking components and you will not select all the rest of the components that are not used for your use case, right? So you can optimize and tweak OpenStack to make it really yours and adapt it to your use cases. It is a self-service cloud experience, so basically you don't go into the same procedures of creating a ticket through a portal like ServiceNow and then wait a few days or weeks to get a virtual machine, right? It's a more self-service approach where you have that multi-tenancy experience, very close to what you can experience in public clouds. Actually, you have that notion of projects, and within that project, you have RBAC, which is enforced, and you can then manage your virtual machines, networks, private networks, and storage services yourself without having an admin to manage that. But obviously, you have some admin level features that are only available for admins, right? It's API driven, and that's very, very important. This means that you can definitely use the UI, and in that case, that's the Horizon UI. But you can also leverage the CLI and any automation tool like Terraform, for example, if you want to enforce infrastructure as a service with infrastructure as code approach. So you can definitely, in that case, use Terraform and create your infrastructure using these Terraform templates, right? And then you have all the core services which are provided by OpenStack. You have the full workload LCM, so lifecycle management, creating CRUD of virtual machines for sure. But you will also have live migration for your virtual machines. You will have VMHA for your virtual machines. And there are some projects in OpenStack that also allows you to do some kind of DRS on top of OpenStack. So the project is called Watcher, right? So this is for resource optimization, right? You have also full storage capabilities in OpenStack, and this is also very, very important because it's not only block storage that is available or file storage that is available, right? So you have volumes as a service, and you have file system as a service, whether it is Samba or NFS, but you also have object storage, right? So that's why when you look at the storage layer, you have object storage with Swift or CephFS, or sorry, not CephFS, Ceph Rados Gateway. You have block storage with a project called Cinder, and you have file system as a service with the project name Manila, right? So you have full storage capabilities. You also have the full networking capabilities. And what I mean by full networking capabilities is you can select your own SDN. You have multiple SDNs that are available and can be plugged into OpenStack. Cisco ACI, Juniper Contrail, Juniper Open Contrail, Tungsten Fabric, OVS, OVN, right? You have a few options that has been integrated into OpenStack. You can create your own SDN controller. Like if you want to use your own SDN controller for IoT, you want to use your own SDN controller for your own use cases with your own overlay, you can override any default mechanism within OpenStack. There is a framework for that with the ML2 plugin mechanism, where you can override the networking procedures there and make it again yours, right? So you have various SDN that you can select and integrate into OpenStack. But the good thing also here is that it does not only manage underlay networks like provider networks, but it will also manage overlay networks, and you can integrate various overlays depending on the SDN that you are selecting. So VXLAN, GNV, GRE, MPLS over VXLAN, MPLS over UDP, right? You have various overlays that you can use with OpenStack, again, depending on your use case. And you have micro-segmentation mechanism that can be integrated, again, depending on the SDN of your choice, right? So you have the default one with Linux net filter mechanism, where you are filtering on layer 3, layer 4, the traffic between virtual machines. But with some other SDNs, like, for example, Tungsten Fabric, managed, through the, the code coming from Juniper. Through that SDN project, you have advanced micro-segmentation, where you not only manage traffic through L3 and L4 layers, but you can also manage micro-segmentation at application layer, so L7 layer, right? So more advanced micro-segmentation mechanism. You also have auxiliary services like DNS as a service, load balancer as a service, secret management with Vault configuration. So you do have all these auxiliary services that give you more capabilities across your cloud, private cloud infrastructure. So saying that, when we've seen the OpenStack environment platform, we've seen that there are some core features within OpenStack that manages virtual machines, manages networks, manages storage, and have all these auxiliary services. Is it enough for enterprise grade ecosystem? Not always, right? We always get questions around, yes, but I have my own storage backend. Like, for example, I have my own pure storage backend. Can it be integrated into OpenStack? Yes, it can be integrated into OpenStack. You have drivers, multiple vendors that have written drivers for OpenStack. These are called Cinder drivers. And there is a list of Cinder drivers that are available and published on OpenStack website, where you can see the compatibility of the storage backend with OpenStack, right? So you have that list of compatible backends that can be integrated into OpenStack. We have customers asking whether we can leverage GPUs and vGPUs with OpenStack. So again, yes, right? We have, as part of Mirantis product, for example, we support the NVIDIA Tesla series, A100, A40 GPUs and vGPUs, where workloads can then run any AI/ML type applications to build machine learning models. All right. Some customers that are building public clouds with OpenStack also need to have billing capabilities. So either they build their own billing capabilities using the APIs of OpenStack. So that's a very common choice, right? So you create your billing backend attached or aligned with your business case or business model, and you have your billing system which is built with that. But you also have off-the-shelf solutions like Cloud 7, for example. Cloud 7 is integrated into OpenStack and allows you to do billing on top of OpenStack. Okay. Some customers would ask us how to do backup and recovery or disaster recovery with OpenStack. And for that, you have solutions like Tridio, for example. Tridio is on the market for a long time now, and we have worked with them extensively on a few opportunities. And basically, Tridio allows you to back up not only OpenStack but also Kubernetes, right? So you have one single solution to back up your workloads in OpenStack, but also your workloads in Kubernetes. And some of the customers would ask us, can I deploy virtual machines with Linux or virtual machines with Windows? And again, the answer is yes, right? You have that full list of compatible operating system that are working with KVM hypervisor. And basically what KVM supports, OpenStack would support, right? So you have that full list of various operating systems, whether it is Linux, whether it is Windows, and some other operating systems that would work on OpenStack. Right? So yes, you have that very rich enterprise-grade ecosystem that can be included into the solution, whether it is Infoblox for DNS, whether it is Okta or LDAP for identity provider, or even Active Directory, whether it is Splunk and Datadog for the logging, monitoring, and alerting side, Vault for secret management, and Cisco ACI for the SDN, right? So all of this can basically be included into the solution, and even McAfee for the security of the host, right? So all of these basic applications can come and be installed on top of Linux and then managed with OpenStack. Is it adapted for large or very, very large flavors? Yes, I've noted this flavor, for example, M5D 24X large. So that's 96 CPUs and 256 plus gig of memory. This can be supported in OpenStack, right? So you have the same notion as managing NUMA sockets and all that in as you do in Linux, right? But then as long as you are able to manage that properly, you can have very, very large flavors of virtual machines that can take a full socket and in terms of CPU and use and have more than 256 gig of memory, right? OpenStack would support CPU overcommit ratios. It would also support in some way memory overcommit, but this is something that we definitely do not recommend, right? At least for production, maybe testing you can, or staging environment, you can do some memory overcommit because the applications are less I would say production critical. But for production environment, we would not recommend to do memory overcommit. But you do have mechanisms to leverage memory overcommit in OpenStack. But CPU overcommit, you can have a ratio of 1:4, 1:8, 1:16, right? Depends on your workload properties. Can it be adapted for IO intensive applications? Definitely yes, right? You have various mechanisms that you can leverage. And that's one of the reasons OpenStack was so popular in the telco space, simply because we were able to do things like CPU pinning, NUMA awareness, huge pages management, and DPDK for some very specific workloads. KVM is the default hypervisor, but I can select other hypervisors in OpenStack. And actually, at some point, there was even ESX as part of the hypervisor managed by OpenStack. Can I have certified applications? Yes, it really depends on the application owner. But if they do want to certify the applications on top of OpenStack, there are ways of doing that. Either they do it themselves, or they have other companies like we can help doing that, for example, and on certifying applications on top of OpenStack. And basically, again, as the hypervisor is KVM, we leverage that mechanism also. If an application is certified to run on KVM, that eases the fact that it will run also on OpenStack, right? And do I have certified servers to run OpenStack? No, you don't need to have certified. Some vendors do certify hardware, and it is easier for then end users to consume the full package because they know which hardware to buy and which for that given OpenStack release. But the idea behind OpenStack, the same as for Linux, was it can run on any commercial off-the-shelf servers, right? So basically, you have any x86 or ARM servers available on the market. You install your operating system on that. That's typically a Linux operating system that you install on that, Ubuntu or Red Hat or SUSE. And on top of that, you would then install OpenStack as any packages, right? One other very interesting thing about OpenStack also is that you can easily manage virtual machines, as we have seen, right? You have that's a standard feature of OpenStack, but you also have the capability also to manage physical machines, right? So in that case, this is interesting because you can have that single cloud that allows you to manage virtual machines, physical servers, so bare metal as a service, but also containers and Kubernetes with a Kubernetes as a service offering on top of OpenStack that leverages the virtual machines, right? So that's interesting because then you have that single platform that manages these three type of workloads: virtual machines, physical servers, and containers using the same API endpoints. So what are the use cases of OpenStack, and what are some of the success stories? You have a lot of actually success stories around OpenStack, right? This is true, and we get that concern from time to time that OpenStack is complicated, or OpenStack is hard to deploy and manage. But you also have a lot of success stories around OpenStack, and I'll explain a little bit the recipe of how to make that a success story actually in the next slide. But you have these examples, these success stories that were able to embrace OpenStack, embrace that the same as Linux, right? For me, I typically compare OpenStack and VMware with Linux and Windows, right? At the beginning of Linux, it was also very hard. You had to a lot of things, a lot of moving parts, compile the kernel, prepare the tool chain, right, to make that work, and then a lot of integration that would come around the kernel to make something a little bit more distributed, a little bit more looking like a distribution. Now it is definitely easier, right? You just download a cloud image, and you have Linux deployed in less than 5 minutes, basically. OpenStack is exactly the same, right? So OpenStack is still a very young project. At the beginning, you had that same I would say approach of having to build not the kernel, but kind of a cloud kernel, right? With these different moving parts, and ultimately make a distribution out of that. And now definitely it is way easier to deploy OpenStack and manage OpenStack, right? You have more tooling, you have more I would say documentation that would explain how to properly do OpenStack. And we Mirantis, we have massively invested into how to make OpenStack easy, with a lot of what we call the zero ops approach, a lot of tooling that allows to do a lot of automation around deployment and managing of OpenStack. So how did where did these customers make OpenStack successful? So you have one type of use case where, for example, you need to build secure sovereign clouds, right? So for that, you need to audit very deeply the code and make sure that it aligns with various security frameworks. Is it NIST compliant? Can I have a FIPS 140-2 certification around that code? Right. So you need to have that capability to audit the code to make sure that it aligns with these frameworks, right? So this is why OpenStack is very, very interesting in this case, because as it is open source, right, it is easier than to take the code, audit the code, and make sure that it is aligned with these frameworks. And if not, then work with the right partner to build that. So we do have a few examples of government institutions building very secure clouds where they have themselves brought their own features to use properly secured operating system and properly secured OpenStack components and deliver services to their tenants using, again, these various security frameworks. Public clouds is something that also is very, very popular to build with OpenStack, right? Why? Because, well, VMs are not going anywhere, right? We know that more and more companies are investing into containerizing their applications or moving them into microservices, but not all applications are adapted for that, or not all applications are. It's not always interesting to move them into containers, right? So we know that that transition is going to take time. So VMs is still going to be in the ecosystem for quite some time, right? So in that case, some of these companies are creating their own public clouds and more sovereign public clouds with addressing very, very specific markets. Like, for example, I want to address the European market, or I want to address the GDPR compliant countries, or I want to address the APAC countries, right? So you do have these very specific sovereign clouds that are typically not then built only with VMware, but also built with OpenStack. And you do have a few examples, again, like STC, so Saudi Telecom, clouds like Cloud VPS, like OVH, right? So they provide these cloud services with OpenStack clusters. These are large-scale multi-region clusters, so you do have that design pattern where you can create these very large-scale, multiple hundreds of nodes, 500, 600, 700, 1,000 nodes within a single region. Okay. Some other examples are building private clouds with for manufacturers, ISVs, financial institutions. So you do have a few examples, again, like Volkswagen, for example, invested into building their private cloud with OpenStack. Reliance GIO invested into OpenStack to build their private clouds. So these are very interesting use cases, because they not only build the OpenStack clusters for their production environment, but also for their development environment. So why would you, for example, put your development VMs on public clouds or on VMware, where you are paying licensing, where you have these license costs, right? These are basically 8 by 5 VMs that can run on OpenStack, and these are very well adapted for OpenStack. So basically, in that case, development or staging environments are very well fitted for that type of environment, and you can then mix between VMware infrastructure and OpenStack infrastructure for both prod and development, right? E-commerce and e-commerce at scale is also interesting, because, again, there are a few of our customers that are handling very, very large scale services on top of OpenStack. Here we are talking about $100 per second type of transaction on that platform, right? So you can imagine the criticity of the platform. And how can they make the platform scalable but cost optimized they need to do that with OpenStack, right? And actually, we have a TCO calculator that we share, and that I'll share the link later, where you can calculate the cost difference between a footprint on VMware and a footprint on OpenStack. And you will see at some point that as you scale out, you have OpenStack that is getting more and more cost efficient because of how you can build the clouds. And then workload optimized clouds like telco clouds, right? So any IO intensive workloads, whether it is networking or storage, can very well fit into OpenStack, because OpenStack leverages a lot of the mechanism that Linux provides. So that's very, very interesting. Like, for example, and again, that's one of the reasons why telco clouds used a lot of OpenStack. Like Orange, for example, massively used OpenStack. The reason for that is, one, it was open source. It was designed to fit on code servers, to integrate with as many third party, whether it is SDN parties and storage parties. And you had a lot of communities contributing to that space. So basically, that created a lot of opportunities for telco to create these open clouds that could integrate various workload vendors. Like in this space, these are called VNFs, virtual network functions, and these were typically optimized for IO networking, intensive IO traffic. So how did many of these I would say organizations succeed with OpenStack? And so, as I said, yes, there is that saying around OpenStack that it is complex, right? It is difficult to manage, and that was true at some point. This is less and less true, right? Again, you have more and more projects making OpenStack more accessible. And Mirantis, we did invest massively into that, so that we are able to make OpenStack as easy as possible. But I think there are 3 big steps as a recipe to make OpenStack a success. One is proper design and architecture, right? And what I mean by proper design and architecture is you need to rely on reference architectures. Reference architectures means that this was used across the field, and it has been vetted, so you don't get any surprises, right? You can build compact clouds with OpenStack. You can build very, very large clouds with OpenStack. You can have hyperconverged or non-hyperconverged with OpenStack. You can have single region, multi-AZ, multi-region, multi-AZ deployments, right? So all of these patterns can be enforced, and all of these have been proven, tested on the field for now a few years, right? So rely on these reference architectures. Be ready also to work on these bespoke solutions with the proper experts, right? You have companies that can help you design your own solutions and give you recommendations on what are the best practices around how to build OpenStack and make it yours. In that design and architecture phase, also, this is where you will be selecting the right hardware, and this is also very, very important. You need to give proper resources, and that's a big difference with VMware. You need to give proper resources to OpenStack so that OpenStack will work properly, right? OpenStack is not made to run on 1 or 2 servers. You can make it run on 1 or 2 servers, like you have that all-in-one releases, but it's not really fitted for that. OpenStack is made to work as from 9 servers and more than 9 servers. And as from these 9 servers, it will scale out up to 1,000, 2,000 servers, right? So you can grow very, very in a very large way with OpenStack, but you still have that minimum footprint that you need to manage. Guaranteed deployment. So how can you guarantee deployment? Is deploy on the right hardware again, deploy with the right tooling so what I call the lifecycle management system to deploy OpenStack properly. Set the parameters right, so with the right amount of resources attached to each of the services of OpenStack. So enough CPU, enough memory, proper configuration for telemetry, for example, proper configuration for overcommit, right? So set the parameters right. And you can start small and then you can grow fast, right? So always think about that, start small and grow fast mechanism. So again, for that, this is attached to the proper lifecycle management. And then finally, manage clusters, right? So manage your clusters with the proper monitoring tooling. Retrieve the right metrics from the OpenStack layer, networking layer, storage layer, to make sure that everything is working properly. Have again proper lifecycle management tooling to do all the day 2 operations. So how to update and upgrade your cluster in an easy manner without downtime. How to scale out, so how to add more nodes, whether it is storage nodes, compute nodes, and hyperconverged nodes, and use that tool also to change your parameters. Like, for example, I want to add a new feature, or I want to remove a feature from OpenStack. Don't go and manage these directly in your clusters. Use source of truth approach with infrastructure as code approach, where you have that single source of truth. You change your parameters there. You go through the GitOps approach and you apply it to your system. And then don't forget about the workloads. I think one of the things that typically is forgotten a lot around OpenStack is, okay, OpenStack is the platform or is the layer, but you still need to accompany your tenants to onboard the workloads on top of OpenStack to make it a success, right? So don't forget about taking care of workload, whether it is workload migration from VMware to OpenStack, or onboarding greenfield applications into OpenStack, right? Again, you have automation for that, Terraform, typical mechanism. You have Cloud Init, typical mechanism to provision your virtual machines, and then it is compatible with Linux and Windows virtual machines, right? So nothing very, very specific here. So this is a typical landing zone, like how we approach things in Mirantis, like design and run in less than 2 weeks. And what we design is we use these reference architectures, we select the proper hardware, we deploy using the proper lifecycle management system. And in this case, this is Mirantis Container Cloud, right? That is used to deploy it on the proper hardware. And then we attach it with the right storage backend, with the right networking backend. We have the proper logging, monitoring, and alerting stack, which is attached to it. And we can do any third-party integration, like with Tradio for disaster recovery, like Okta or Active Directory for identity management, Pure Storage for third-party storage with an appliance, right? And a storage appliance, right? We can all do that and make that work within a few weeks. We rapidly talked about cost, and I think this is also very, very interesting, because if you look at VMware, for example, it is a little bit complex in the sense that you have various licenses attached to various features. Like you would have your vSphere license, and then you'd have your NSX related license, vSAN license, Tanzu related license, and all that, right? So then you just stack up, and you need to manage that with OpenStack, and that's the reason why you have that. When you look at the TCO calculator, and if you go to that link, you will be able to rapidly see the difference as you scale out. With OpenStack, it's a node subscription, and it's not a license. It's, as it is open source, it is a support subscription, right? So this means that you will only count for nodes. Like with Mirantis OpenStack, you will count nodes, whether it is compute or storage nodes. You only count for nodes, but you don't count for the resources. You can have massive machines with a lot of CPU and memory, and the cost will be the same as if you have smaller machines, right? We don't count the number of CPUs, we don't count the number of sockets, and we don't count for the features. You have all the features included into the offering, and you only count for nodes. The same for storage. We don't look at whether you're using NVMe or SSD or spinning disks and the size of these devices. We only count for nodes, right? If we look at that I would say model, this means that it is one, simpler, and two, it can be very, very cost effective as you scale out your cluster. So we talked about OpenStack as a logical path, I would say, right, from VMware towards that open source platform, which is also managing VMs, and in that case, that's OpenStack. That seems to be a very logical path. But we can also have a disruptive approach with Kubernetes, right? And I'm not saying that it is exclusive, meaning that you need to use OpenStack only or you need to use Kubernetes only. Obviously, at some point, it can be mixed, right? It can be mixed to have OpenStack on one side and Kubernetes on the other side. It all depends on your use case. It all depends on the footprint of the infrastructure. But you can have that disruptive approach with Kubernetes. If we look at the general 3 Rs methods, right? You would have rehosting, you would have replatforming, and you would have refactoring, right? And you can see these different paths of I need to rehost, I need to replatform, and I need to refactor. There is no straight answer on which one would be the most time-consuming. But typically, from experience, we can see that rehost and replatforming is a little bit easier, simply because basically you don't need to have access to the source code, but you only need to repackage through automation, typically, and proper tooling. You need to repackage your applications into the new format. So let's say, for example, you want to rehost or replatform from VMware to OpenStack. You need to migrate a VMDK format into a QCloud2 format, for example. If you want to rehost or replatform from VMs to containers, you need to take the binaries in VMs and put that into a container that would be able to run these binaries. So it's mainly about automation and proper migration tooling than actually changing the code. Refactoring is definitely a little bit heavy lifting, a little bit more heavy lift than rehost or replatform, simply because there you need to have access to the source code. You need to redesign properly the code and move that from a monolithic application into microservices when that makes sense. And then once you have done that, you go through a full process of testing the source code to check if you don't have any regression, and then you start to deploy these in your environments, right? So definitely this is a little bit more heavy lifting, but you do have these three paths. And what typically happened around whether some companies decided to migrate into public clouds or other alternative virtual infrastructure managers like OpenStack, they basically use the rehost or replatform approach for this. And when it came to Kubernetes adoption, they used the refactor approach, right? It was for them a good opportunity to change their applications and make them more cloud native, between commas, and put that into Kubernetes platforms. But what I will show in the next slide is that you don't really need to have that single approach of, okay, rehost, replatform, this is from VM to another VM platform, and refactor, this is from VM to container platform. You do have other alternatives for that. So here what I'm showing is, in terms of timeline and strategies, you can have a different approach. So if you look at strategy 1, and that's what I was explaining, if you look at strategy 1, you have your applications, and you start to refactor these applications, right? So you start to refactor them and move them into microservices, again, when that makes sense. You can still refactor application and keep them as in monolithic form when again, it makes sense. But typically, many companies, many organizations move them into microservices. In parallel, you will have to start to deploy and maintain your new platform. So in this case, Kubernetes platform, right? So this is being done in parallel, so that you can start and develop your applications and test your applications on this new platform. Nevertheless, you still haven't shipped that application on production. So you still need to maintain your legacy platform and legacy applications in the same state as initially, right? So what will happen in this case is you are investing into refactoring your applications. You are investing into having that new platform, and in parallel, you are maintaining your existing platform, right? And all of this is still I would say is still done at full scale. At some point, once you have your applications in the proper state and you start to deploy these in production environments, you will start to phase out part of your legacy applications, right? And typically what we see on the field is that full process here do take time. Depending again on your application portfolio, it do take time simply because depending on the complexity of your application, depending on the scale of the deployment, it will not take. You don't see it in weeks and months. You see it in years of refactoring, right? So this is a very typical approach, but this is an approach where ultimately you know that it will take time to refactor all your application portfolio, and thus it will take time to phase out your legacy platforms, right? And what it means, it means that you will have to support and maintain multiple platforms, at least 2 platforms in parallel. And that also means that it comes with operational complexity and cost associated cost. Okay. Now, if I look at another strategy, which is let's consider rehosting and replatforming also for Kubernetes. So in this case, what will happen is that I start to deploy my Kubernetes cluster, right? But right away, I don't refactor my applications, or I don't need to refactor my applications, but I can rehost these monolithic applications, right? So I start to move applications directly from the legacy platform into Kubernetes. By doing this, I can start to phase out my legacy platform. And this reduces the need to manage or maintain 2 full setups at the same time, because you have created one setup and you're slowly moving your applications from your legacy platforms. So let's say VMware, for example, and you're moving that into Kubernetes, right? So you are slowly phasing out your VMware footprint and you're slowly increasing your Kubernetes footprint. So you don't have that effect of I need to manage and maintain 2 platforms in parallel, but I'm slowly reducing one and I'm slowly increasing one. So your applications are being moved towards the new, I would say, modern future-proof platform. By doing this gives you more time to then start to refactor your applications. And you will be start doing the refactor of your applications into microservices into that same Kubernetes cluster. So you see that here with strategy 2, you are taking the problem in a different direction or different side by saying, I need to go on Kubernetes, but for that, I need to change my applications towards something which is, I need to go to Kubernetes, but I will start to move my applications into Kubernetes first, start to reduce my footprint on VMware, for example, and then ultimately, I will start to refactor only the required applications, right? So that's strategy number 2. And typically for this strategy number 2, the rehosting will take weeks/months, right? So we know that in this case, we are going to adopt this platform way more quicker, simply because the migration in rehosting and replatform mode from VMs to containers takes weeks/months, depending on the number of applications that you need to migrate. And then you will take the time that is required to refactor your applications with the reduced risk, right? So these are some of the timeline and strategies. And this is where actually that approach, the strategy 2 approach, can be seen as a disruptive approach, because many of the companies don't think of Kubernetes as being the host or platform. They see more public clouds and migrating from VMware to EC2, for example, as the best approach, which is not really the case, right? Because of, again, if we remember the start of the meeting, you still need to take into consideration the cost of the migration for these applications, the VMs running 24/7 in these public clouds, how much that will cost you, and ultimately how you're going to move out of these to put them into that modern world, right? So you need to take that into consideration. That's why running them into Kubernetes may be the proper solution for you not to be locked in at any point. So how will Mirantis help you in this case? We know that deploying on Kubernetes can be made very, very easy. Here I'm talking about a reference landing zone where I'm deploying the container engine, deploying the orchestration for Kubernetes with Mirantis Kubernetes engine. I'm deploying the private registry with Mirantis Secure Registry. I'm deploying the logging, monitoring, and alerting stack for observability, and adoption accelerator with Lens Autopilot, right? So this setup deployed with an infrastructure as code approach with Terraform, can be designed and run in less than 1 hour, for example, right? So it also helps you to see how easy it is for you to start to deploy that Kubernetes engine rapidly, start small, and then grow super fast, right? So if I go back to that initial slide or previous slide where we are talking about timeline and the time it will take you to deploy the new platform and maintain that new platform, this is where having a proper landing zone reference that can be deployed very, very quickly is super important. And again, independent on the target environment. That can be in private clouds, that can be in public clouds, that can run on physical machines, that can run on virtual machines. It's completely agnostic of the target environment. If we want to look at the same picture, but in this case, we want to host Kubernetes on a private cloud, this is where the concept of LOKI is interesting. So Linux, OpenStack, Kubernetes infrastructure. So a full open source infrastructure where you are using an open source operating system, Linux, an open source cloud, OpenStack, an open source container orchestration, Kubernetes, to provide your infrastructure, right? So you have your private infrastructure, you have your virtual machines handled with storage, networking, and then you deploy Kubernetes as a service on top of that to be able to host or rehost your applications from VMware into containers, and these containers running in VMs, right? There is also a new approach that we are seeing, and that is getting more and more popular. And this is associated with one of the initial points I made, which is VM is not going anywhere, right? So we know that we'll still have these VMs for quite some time now. But some of the organizations, if they are going to invest into migrating or using that future-proof platform, which is Kubernetes, will always say, or we may say that, yeah, but how am I going to manage my existing VMs, right? So we've seen that approach of, okay, we are going to phase out part of the legacy platform. But we can also then see that, okay, if we are going to invest into using Kubernetes as that future-proof platform, then we can also say that we can migrate some of these VMs as is without putting them into containers and put them into VMs into Kubernetes, right? And how we do that is through the Kubevirt project. So Kubevirt project is very interesting because it allows you to leverage all the Kubernetes, I would say, principles, like using the same networking between containers and VMs, using the same storage backends between containers and VMs, leveraging RBAC for both containers and VMs, right? So it eases a lot of things because both workloads will be under a single control plane. So you integrate Kubevirt into the Kubernetes cluster. So here I'm just explaining how we could do that with K8s and then ask K8s to manage both containers with kubelet and VMs with Kubevirt. libvirt and KVM are used under the hood to manage these VMs. So your VMs you don't need to rebuild completely your VM. There is a tool chain that you will need to adapt to manage your virtual machines. But these virtual machines are handled ultimately by libvirt and KVM as the hypervisor, right? So you remain under that same compatibility environment. And you get the advantage then of easily connecting your containers with VMs. You get the advantage of using the same storage backend. You get the same advantage of exposing your workloads the same way using ingress and load balancer mechanisms. So it's very, very interesting in that case, right? So in that case, if we look at the plan, then we can say, okay, I have my legacy platform, VMware. I'm going to invest into that disruptive approach of using Kubernetes. And in that case, what I showed here is Mirantis Kubernetes engine. So I have that as my target environment. I start to move my applications, so rehost and replatform my applications from VMware into containers running in MKE. I will at some point look at specific applications that needs to be refactored. I will refactor these applications to run into Kubernetes. And I can in parallel look at some of the virtual machines running in VMware that I didn't or couldn't move into containers that I'm going to transform into VMs that are compatible with Kubevirt, right? So I have my target environment, which is Kubernetes. I have my legacy environment, VMware environment that I'm going to phase out or slowly phase out or reduce drastically so that I have reduced licensing cost. And I have that future-proof platform, which is Kubernetes, where I'm going to run rehosted containers, refactored containers, and some workloads that have been migrated from VMware into Libvirt-compatible VMs. All right, so let's recap what we have seen. What we have seen today is you do have alternatives from closed source solution to open source solutions. Open source solutions is not a concern anymore. We've been using open source for more than 30 years now. We have field-proven open source platforms like Linux, databases, message queues, infrastructure management, and containerization orchestrators, right? So I think that there is nothing to be concerned of when it comes to open source. And one of the biggest advantage of open source is that you can create bespoke solutions. You can use simple reference architectures and make it yours. You can change the code, you can adapt the code, you can tweak the different components to again make it yours and adapt it to your use cases, your environments, your workloads, right? You need a super secure cloud, you can make it. You need a cloud steered for AI/ML, you can make it. You want a cloud steered for data analytic, you can make it, right? So you can steer these clouds for your choice use cases, adapt it to specific hardware, adapt it to specific use cases like IoT and edge use cases. But you also need then to make sure that you are getting guaranteed success. And for that, we have recipes. And these recipes is take back control using open source, but also make sure that you are working with a trusted partner that will help you deliver faster. And what I mean by this, help you to design your infrastructure and integration components that needs to be integrated on top of that infrastructure. Work with partners that have a track record on deploying and maintaining these infrastructures, and work with partners that can help also your teams and customers to onboard applications on top of that platform and get the most benefit from that given platform, right? Thank you very much. Before we end this meeting, let me just give you some insights on what will be coming from Mirantis. So we will be delivering another webinar November 8th related to how you can leverage FIPS 142 validated encryption for Windows containers, right? So if you're interested, do not hesitate to register to this webinar. This will be also hosted on BrightTalk. And we also, as part of Tech Talk, Mirantis Labs, we will be talking about how we can use a new project that Mirantis developed, a very innovative product called K8s Motron, and how we can use K8s Motron with CAPI to do a full cluster lifecycle management system and manage any day two operations, right? So this is also a webinar that will be hosting on Mirantis Labs, November 14th. Do not hesitate also to register to this webinar. If you need to learn more from Mirantis, we have a press where we provide some free ebooks. So again, feel free to go to this link and download these books. We have a blog. We have multiple blog resources and a few tech talks that we provide through the Mirantis Labs. If you have any comments and suggestions, do not hesitate to reach out to me. If you want to have specific talks or want to learn more from our products, again, feel free to reach out. I wish you a good rest of your day. Thank you for your attendance today, and looking forward for our next webinar. Thank you very much.